big thanks to Labor Party, devICT for letting me do this the second time. So yeah, let's just get started. Let's talk about React. Okay, so let's talk about myself first. My name is Brian Simpson, sort of. And I work at a company called RMS. It's also known as Risk Management Solutions. So I'm working on an application that we're using to help reinsurance companies determine catastrophic risk. So basically, if you reinsure 1 million houses in New York City and a hurricane hits it, how much money do you owe? That kind of a thing. Kind of interesting. So if you want to follow along with this presentation, you can go here. This is on my GitHub. It's react-app-presentation-June of 2016. Pretty easy instructions if you want to follow along. So I think it'd be good to talk about what this presentation isn't, namely what it's not going to really cover. So it's not a Webpack tutorial, so I'm not going to teach you how to set up your app using Webpack. I'll briefly go over my configuration settings, but that's a bit of an in-depth conversation that doesn't belong here. And I'm not here to compare this framework with other frameworks. That's completely outside of the scope of this. I'd be happy to talk about it after the presentation, though, if you are interested. So what is React? What is Flux? What is Immutable JS? And more importantly, what does it give you, right? So React, we'll start there. So it's a framework, right? And it's decorative, right? So in layman's terms, what this means is that it abstracts everything in terms of DOM manipulation, right? So there's no more like writing your code and saying, hey, DOM, give me that element with that class, and then do something to it, and then you do that over and over, and you write a bunch of this stuff, and it gets really hairy, right? Not at all in React. The way it works is React stores an internal state of the DOM. It's called the virtual DOM, right? And anytime props change, what it does is it juxtaposes it with the actual DOM, and using its algorithms, it determines the best way to get from here to here based on property changes, right? So it sounds kind of expensive, but it really isn't if you're smart about how you put together your components. It's actually quite fast. More on that in a minute. So it's component-based, right? I just touched on that. So React doesn't have things like directives or services or whatever. It doesn't have a lot of abstractions for you to use. You get components, and that's pretty much it. But the way it tends to work is that you have one component that then consumes a couple of components, renders those out, and it goes down in a tree, right? And because it does it this way, the data flows unidirectionally from the top down at the bottom. So when it comes to making those virtual DOM comparisons, that's actually where it gets a lot of its power, is by having the data come from one direction. It's really easy to see what changed and what didn't. The other thing to note is that React isn't like a lot of other frameworks in that it only provides views, right? So it doesn't give you a layer between your API and what you're actually showing to the user. So here's an example of a React component. Let's just dive right in, right? So here we're creating an info card, right? So we use React's factory method called createClass. And what this will do is we pass in a list of functions, in this case render, and then it'll wrap it in a React component. And then down at the bottom, we render it out using React DOM. So what's happening here is down at the bottom where it actually renders out the info card, we're passing in the name Jill and the job police officer. And then inside, you can see there, you have the interpolation in between both of the divs. And that's where we're actually plugging in the prop. So the result of this, right, is that you'll just get a little section widget, right, that has 2 divs inside, but with the props that you passed in. Now, if you haven't used React at all, this looks kind of shocking because if you look, right, we have HTML in our JavaScript. Like, what the hell? It's a little odd. But the thing is that, as web applications have progressed and as we've learned more about how to structure our web applications, we've realized that I think a component-based approach is a valid approach and actually a quite good one as long as you're on board. The idea that all of your styles, all of your markup, and all of your JavaScript live within one contained component. It's a little outlandish, but it does simplify things, and we'll see that when I show you the application. So you can also use ES6. I don't prefer using classes from ES6. It's largely a preferential thing. If you buy into the object-oriented Java approach, then this might be for you. But at the end of the day, they're doing the same thing, right? So there's also one more cool thing that React gives you. These are called stateless components, right? So if you look back here, right, we're looking at, let's go back to this one. You see that we're passing in the render method, right, on this object that we pass into React.createClass, right? So render's not the only method. There's quite a few methods, and we'll talk about those in a minute. But what a stateless component gives you is it gives you just the React, like the render method, and that's it. You don't get a state object. You don't get access to anything but props and spitting it out. So it's almost like a Lambda component, right? You just pass in your props and it spits out something and that's it. There's no more complexity. They're pretty useful if you have a lot of shared components. You can make a lot of stateless components that you can reuse all across your app. So let's talk about a component, what it consists of, right? So its primary things are state and props. So state is the internal state of the component, and props are properties that you pass into the component. So for example, you'll have a root component and it has some data and it calls, say, a navigation bar and it passes in the links, right? Those links are properties, right? But if you choose to maintain the state of the navigation within that component, then you would use state and say, currently selected navigation item is whatever, right? So that's your state, but the props is the stuff that you pass in to make the component render and function the way it should. And what I talked about previously, we've got lifecycle methods. So in addition to render, right, you can pass along a lot of different functions inside of the object. So you can pass along component will mount, which gives you a hook into whenever the component actually is created. You can check the props, do things, instantiate things. And then inside of component will receive props, like every time new props come in, it'll call that method. So there's a lot of flexibility with where you can alter your data and actually parse it. So there's a couple of other features too that components give you. So this one's actually pretty cool. So if you're not using like TypeScript or you're not trying to enforce types, prop types gives you a sense of validation for every component, right? It's essentially a contract of what this component expects. So in this case, right, our info card from earlier where we passed in a job and a name, here what we're saying is explicitly that, hey, if you pass in a name prop, it needs to be a string. If it's anything else, then you'll get a console log error that says, hey, check this render method. It looks like you passed props in incorrectly. So this is particularly beneficial because it helps prevent breakage. It gives you easy validation that your component is going to do what it's supposed to do. And so if somebody changes a component up here that affects a component 2 layers down, right away. One thing to note here is that prop types, these validations do slow down the app a little bit. So whenever you actually deploy a React application, it is recommended that you bundle it with something like Webpack. And then as you bundle it, you turn on production mode, which will then disable the prop type validations. So that way, if this is running in production, a client won't see the actual error message if something were to break. So the other thing that it also gives you are mixins, right? So mixins, if you're less familiar with the concept, it's basically just a glob of code that we combine with another glob of code, right? So in this case, what we're doing is we're creating a mixin up here called subscribe component to event. And what it does is it calls component will mount, it hooks into component will mount, and it adds a change listener. And then on component will unmount, it removes that change listener, right? So the reason that this is particularly useful, right, is that inside of your component, instead of rewriting this for 20 components, you can just make a mixin, include it like this. You include each one inside of an array. And then all you got to do is just subscribe essentially to the mixin's interface. So here you can see that, okay, the mixin is requiring that the component has an onChange function to pass in, right? So all I have to do is make this onChange function, and I know it'll always get called, excuse me, every time that this event fires, right? So it's a pretty powerful concept if you understand the implications, but generally speaking, you won't dive into mixins very quickly. It's good to note that mixins are not available in ES6. It makes sense because given that they use like keywords like extend, you favor more of a object, like a composition approach as opposed to using mixins. So you'll compose several components together using ES6 syntax over using mixins. And another thing to point out too is that one of the mixins that React gives you out of the box is called pure render mixin. This is a really important concept. I'm not going to cover it entirely here, but what it does is it basically listens inside of your component on should component update. That's a lifecycle method that determines whether or not the React component should re-render or not. So pure render mixin, if you apply that to a component, it will essentially compare the props between the old state and the new state at a shallow level, and if they're same, or if they are the same, then it won't render, right? So if you can guarantee that your component is completely pure, right, and that your input always guarantees the same output, then you can use pure render mixin, and React will be more intelligent about how it renders your components. There's a caveat though with it, because if you were to attach pure render mixin and the top level components, there was a change, but your structures are just simple objects, right? It's not actually checking every property. It's checking the references on every single object. So if you have nested objects that you're passing in props and using pure render mixin, you might get false positives, or excuse me, false negatives, in that it won't render even though new props showed up. So to address that, that's why we would use something like Immutable, which we'll talk about after Flux. So Flux, right? Now, what I talked about before with React is that React is just your views, right? So to actually get data to pour into your components, into your view, you can use something like Flux. It's important to note there's a couple of other implementations. Actually, there's quite a few. It's really confusing. There's Reflux, Redux, all these different approaches to it. My recommendation would just be to pick one and roll with it. But it seems like Flux and Redux have the most traction at the moment. So diving right in with what Flux really is, right? It gives you a dispatcher, it gives you a store factory and actions, right? The way that this works is that you have a Singleton Dispatcher, right? So this is essentially just a pub sub dispatcher. And what it does is whenever it receives a new action, right, that action inside details some change to the store, right? So the action might be, hey, the user clicked on the button, right? So then that action gets sent to the dispatcher, and the dispatcher's like, okay, so all the stores that wanted to know that this button was clicked, it was clicked. So here's the information, right? And then your store will be listening to the dispatcher, receive those components, do whatever it needs to do, pass it along to the view, right? One exception to this here is that you can see this little line that draws the action from the view to the dispatcher. That is how the entire application will work if you're using React with Flux. The idea is that your views will fire off an action saying, hey, we did something. Dispatcher receives the action, tells us all the stores that are subscribed to that event and say, hey, this happened. Stores do whatever they want to do, pass the props in, back to the view, everything re-renders. And it does all of that in cycles. The advantage, again, is that this really supports the unidirectional data flow that we're looking for, right? When our data flow only comes in from one direction, it simplifies everything a great deal. You don't have to worry about some random thing firing off an event, something else firing off an event, trying to reconcile those, and you're like, oh shit, erase condition, what am I gonna do? And right, it's just a big lump of data, and you just push it on down to the view. So I mean, that's Flux, right, in a nutshell. And we'll talk about more implementation details with the app. So Immutable, right? So what is Immutable? What does it bias? Immutable is just a library that provides immutable collections. The most prominently used ones that I've seen are just list and map, but it also gives you an ordered map, a sequence, some other stuff. I can't entirely remember, but it's very powerful, right? Now, the reason that Immutable is so powerful is that before, when I talked about comparing the props using pure render mixin and how it only does it at a shallow level, the reason that that's relevant here is that Immutable, right, when you, do operations on a collection and, you filter it or you map it or do whatever, anything that you don't touch still maintains the same reference, right? So if you have an object, but in this case it's a map, right, you set one key to something else, all 9 keys that you didn't touch will still point to the same object, right? So, when React does its check with pure render mixin, then you'll know, hey, okay, stuff is, did not change, right? Now you could do actual property comparisons, right? So like instead of using pure render mixin, you could say, hey, is this property equal to this one and this one equal to this one, right? But then you're mapping through, dozens of properties potentially, which is very slow. So obviously the reference checks are what we want. So let's dive into an example. And I've said dive in like 3 times, so I'm gonna stop. All right, hold me accountable. But we got here, right, a constant. This is a value map. Now, what we're doing here is we're going to iterate through this existing array. And then what we're going to do is we're going to say, hey, we only want stuff that the value map provides. And then what we're going to do is we're going to say, okay, go ahead and give us the value inside the value map. So we set up an immutable list. And the way that works is, you just pass in the JavaScript equivalent, and then it'll automatically make it into a list. Down here, what we do is we run existing array, and then we just filter over it using this as our condition. So it'll just call this method with the value of the array. In this case, it'll be 1, 2, 9, and 10, and say, okay, does this value map have that property? Well, it doesn't have 9 and 10, so those get nilched, right? And then inside of map, we just take the value again, pass it into value map, right? So then we're getting back foo and bar instead of 1 and 2. So if you look, we go from 1, 2, 9, 10 to foo and bar, right? So it's kind of a complex first example, especially if you're not familiar with functional concepts. But really what it does is it helps you write code very succinctly. It guarantees that you don't have to do, Tanner, what's it called? Protecting your variables. It's like, no, I can't remember. Like, do what? No, that's not the word I'm looking for either. It's okay. But basically, the point is that you don't have to worry about whether or not your stuff has changed, right? It only changes if you reassign it. There's nothing that happens by reference, right? If you do a traditional map using JavaScript, it'll also do the same thing. It'll just return an unedited array, right? But there's a lot of different iterations that you can go through, and it actually, depending on how you write the code, it will actually overwrite the object. So to demonstrate that, right? Sorry, that was a little convoluted. If you look here, where I filter map through this array, you see it returns this. But if I console log existing array, it still has the old value, right? That's what I mean by mutability. The idea is that I run that, and it doesn't change existing array, it just mutates it. So the idea is that you create functions, and then those functions return the results of these chains, and then you take those results and then you do something with them, right? So the idea is that you just kind of compose all this data. It's kind of confusing at first, but the payoff is huge. So yeah, let's dive right into this app. So I'm just going to actually pull it up, and we're going to walk through it, and you can see some of the code, how things work, blah, blah, blah. Can everybody see this okay? This is kind of a brutal big text for me, so we'll see how this works out. But first, let me show you what we're actually building here. So that would probably be helpful. So what we're going to do is turn off presentation here, into the app. I already ran npm install, so it's all good to go. So I just have to do npm run start. Now what this does is this boots up my Webpack dev server. So I have it set up so it does hot loading with the components and some other fancy stuff that makes it kind of easy to work with. But the setup took forever. So, weigh your options. So why don't we start with the Webpack config. So we require Webpack, right? Entry point into the app. Again, I'm not going to talk too much about this because it's kind of convoluted, but if you do know Webpack, this is how I'm doing it. So got some loaders. The one thing here that's good to note is I have all these aliases. So whenever I require anything inside of my components, instead of keeping track of the root directory, I just say, hey, give me actions. So we'll see that in just a minute. So we'll just go ahead and move right into where the app gets started. So as of like 2 versions ago, they split React DOM and React into separate libraries. They used to be one and the same. So if you see some tutorials, know that they're different now. So what I'm kind of doing here, right, is here's that alias coming into play, right? You save 2 characters, so it's not really that worth it. But, if you move your stuff around, it could be worthwhile. So anyway, if you look here, right, I'm acquiring this root component. This is kind of basically Webpack will, whenever I require the CSS files, it will actually, concat them to a final output CSS file. So if I was really cool, what I would do is I'd set it up so that these are all encapsulated within the component so that your styles aren't overriding. But I didn't do that because it was extra work. But know that that's a possibility. using Webpack's CSS loader, I believe. So anyway, I just made up this little standard that's kind of saying, hey, I'm not using this for anything. It's just kind of there. And then the only DOM manipulation you have is you find where you're going to put the app, where you're going to spit it all out. And then we render the root component and send it in there. So the actual boilerplate's pretty simple, but let's actually take a look at the root component. So this is a little complex, so we're going to simplify this just a little bit because we don't need to see all this garbage. Actually, wait, I'm getting ahead of myself. Let's actually look at this thing and see what it is. That way we know what we're building, right? I think it's 8,000. No, it's 8080. There we go. All right, cool. So what we're building is a weapon viewer for a fake game called Laser Dragon Brawlers, right? Super creative. Now, and the way this works, right, is that you just select two weapons, they put them side by side, and then you can look at what you got, right? So let's check out this cannon destruction. So guys, I'm a sick designer. I know you guys love these colors. So as you can see, we've got two attacks. One that swipes and one that pokes. Get off of my lawn, right? And so it's like, okay, well, let's compare it with this blow dryer. So then the blow dryer pops up here. And it's like, okay, so this blow dryer kind of sucks, actually. It doesn't really do anything. Okay, so I compared that. Spaceball's the flamethrower. So kids love this one. So these are all really stupid weapons, right? Oh, and we have a staff that you can use to summon dads. Namely Jim. So he's actually got two attacks. He can do his taxes, and that'll bury the enemies with paperwork, or he can grumble, right? It's an area of effect attack, guaranteed to make everyone feel uncomfortable. So lots of, it's super goofy. It kind of looks like crap, but yeah, woo! But it does like illustrate what React is capable of. And we'll show that in just a minute. But yeah, as you see, I just select whatever. And it compares everything. So now let's actually dive back in and look at code, because that's what we're here for, right? So I've got all my store integration stuff in here, and I'm currently clearing it out so we can get a basic idea of what we're doing here. So what we got here, right, is our main root component, right? And it's debatable how you architect your apps, right? Mine is architected in the sense that there's a single root component that gets all the state, and then it boils down. The most important thing to take away from this, though, is that you can't really be dogmatic about your structure when it comes to these React apps, because more than likely what will happen is that if you use this for an actual client-facing project, you'll end up with tons and tons of components. And managing state, just like anything else that gets monolithic, can get pretty rough. So it's really important to make sure that that you're cognizant of what's happening as you're writing the code, right? It's easy to get carried away and then be like, oh crap, this is really hard to manage. I mean, everybody knows that, but the point is, though, is that because React doesn't force you into a strict guideline, it's just important to be open to other possibilities. So if we actually look inside here, right? So we're looking at the root component. We have that inside our components directory. And as you can see in here, we have our styles and our JavaScript. So what I do is I grab the weapon list, which back here, this is the weapon list. And then the weapon canvas, which is this giant block that says no weapons added yet, right? So I basically got two components and spitting those out. So we've got the wrap, and we put them together, style it all up, and then you end up with this, right? So what you'll see here is that we're passing in state objects. And normally when you integrate a store, right, what happens is that at your root component, you set the state with what was in the store, and then you pass the state items down in. So as you can see here, we're assuming, hey, we're getting the selected weapon IDs from a store. And then let's take a look at this one. So we're getting weapons by selected IDs, right? So here's a good example of immutable, kind of in the flesh. So to make it read a little bit easier, let's kind of simplify the syntax. So the way this works, right, is that when you're selecting these, you're basically taking the ID of the weapon and you're pushing it into a list, right? It's as simple as it gets. But when we actually spit them out into the canvas, we need the weapon details. We don't need just the ID, right? So what I selected to do, or opted to do, was to have a separate array that has all the IDs, and then I use those IDs to grab the weapons I need. So I map over my IDs and say, hey, give me the weapon ID from every item in that array, and then go ahead and grab the actual weapon and populate the list. So from here, right, you go from 1 and 2 to what those weapons actually signify, which I think in this case is the Jim Rice staff and the blow dryer, right? So super good stuff. Now, let's actually look at weapon canvas. Or no, let's start with list. That one's a little more interesting. So in here, right, so this is prop types in action. So as you saw before, we had selected weapon IDs and weapons. But the catch here is that React doesn't actually have immutable prop type checkers out of the box. So where I work, we actually use immutable prop types. It's pretty slick. But in this case, it's pretty simple. It's just kind of like saying, hey, I need this list and I need this list. And so if you actually don't pass it in, right, it'll give you the error. And that's because of the is required here. So if you don't have is required, basically if you pass in something to weapons is the only time that it'll actually validate it. So if it's not required and you don't pass it in, it's not going to bark at you. So if you want it to bark for you not passing in the prop at all, then you want to use is required. But since we control most of the calling code, I didn't really go crazy with it. So we've got this header pulling in the nav title, which I hoisted up here into a constant. That's just my personal preference. You know, you could put the string right in there, but I find it easier to read by having that stuff abstracted out. And then in here, right, what we're doing is we're going to go through all the go through all the weapons and map over them, and then spit out a list item for each one. Now the cool thing here, right, is that when you're actually using, and this is called JSX. I have no idea how I just managed to slip past that little detail. But yeah, so with JSX, you can actually pass in an array of DOM elements, and it will still intelligently render those out and take care of it just fine. So that means that I don't have to like flatten this out or destruct it or like do anything magical. What I can do is I can just, inside of the map function, just return the JSX element. So it's actually kind of cool that way. So yeah, what I do here is I grab the ID from the weapon. Now, I haven't really talked about this much, but whenever you interact with an immutable structure, it's always going to be with a method, right? It's going to be get, set, filter, map, whatever. You're never actually going to be editing the object because it's immutable, right? So what we do here, for simplicity's sake, we grab the ID, pass it in as the key. I'll get on that in a moment. We get the class name for the current item, and then we pass in an on-click event, or sorry, handler, and then we pass in the name itself at the bottom here. So to talk about this spot specifically, right? Generally speaking, inside of your render methods, you're going to want to abstract as much as you can. And the reason I say that is because it's a lot better, you know, to read this, you know, because this is the code that I use to get the class, right? It's kind of bloaty, and if that was up in here, it would, you know, totally be a pain to read. So abstract early, definitely, whenever you're writing anything in terms of prop manipulation inside of like a React component. And honestly, you could argue here that you could take this out and actually make it a method so that it would be like, you know, this dot render weapons. And that way, you know, that's even easier to read, right? You know exactly what's happening. You're saying, hey, here's a list, and render the weapons inside of there. So it's self-documenting, and it makes it easier to read. So I highly encourage it. But obviously, I kind of just threw this in here. So anyway, so we get the class name. Now, if you notice before, there's a maximum on how many you can select. So you can see here, I can't click on these. So the reason that that works is we check here, right? Hey, so is the weapon, you know, is it selected, right? Whenever you click on it. Okay, well, yeah, it is selected. So, you know, return the active class. So the thing is, though, is that if it doesn't include it, right, at that point, you're like, okay, well, if there's only one item selected, it doesn't need a class. It can just look default, right? They can all be selectable. But when you have the maximum selected, you should probably tell the user, hey, you can't select anymore. So what we do here is we return disabled if the size reaches the selected size limit. So Trying to speed up a little bit here for time's sake. That is essentially how this will work, right? But the cool thing here, right, is that this is the first foray right into our Flux pattern. So at the top of the method, or sorry, at the top of the component, I bring in UI actions, right? And what I do is I call this action on it. So it toggles the selected weapon by ID, right? I think it's important to make these pretty clear so you know exactly what you're doing. So what we do is let's go actually look at what it does. So toggle selected weapon by ID, okay? Well, what happens is that whenever you call the action, right, it calls this method right here. And then the method itself is what actually dispatches to the app dispatcher with the action and the ID. So now we're going to go look at the store. Put it all back there. So we look at the weapon list store. Wrong one. UI store. Now, it's important to note here that this selection process, you can use state for this, right? We could have used set state, said, hey, these are the selected items, whatever, right? That's totally a valid choice. I think usually when you're trying to pick between state and props, the biggest thing you want to consider is how simple is it, right? Because if it's complex, you don't want it in the component. Do you want it to persist? So if the component shuts down and you come back and you reinstantiate the component, do you want the user to be able to pick up where they left off? Because state gets erased every single time the component gets unmounted from the DOM, right? So in a lot of cases, what I'll do whenever I'm working in a React project is I'll just make a UI store for a particular piece of the app, and then that keeps track of things like, hey, what's selected, or what do we put here? Things that don't necessarily deal with the data specifically, but deal with the UI. And again, you could use set state for a lot of this, but it's been my experience that as you get larger and larger component trees, you're going to want to avoid set state most of the time. But it's not an evil thing to do. So moving on, I've got these actions. So I wrote some abstractions here because when you look at the actual Flux examples, they tend to have a lot of bloat on them. So really what I did is I set up, here's essentially my store, right? I've got selected weapon IDs, it's a list, and here's the methods you can use to interact with the store. In this case, you can select it or you can be selected, and that's it. And here what we do is we create a store, right? And what we do is we combine these four methods, nodes, event, emitter, because they actually do that in the example, so I figured it was fair game. And then an empty object, just to make sure that we're not overwriting anything, because assign will mutate the first object that you pass in. So why this is useful is that we get these methods that allow the store to actually listen in changes, or excuse me, it allows components to listen to store changes and then update themselves. These are primarily only going to be used by your root component, but again, as apps get bigger, there might be exceptions to that. Then we have these action handbooks. There's a lot of abstraction here that you could probably clear away. This will toggle. So this will toggle the weapon by the ID, right? So this is actually what gets called whenever the action fires off, right? So the action says, hey, the user just toggles the selected weapon, and then the action then dispatches that event out, right? So the store receives that and calls this, right? The way that works is here. So this store registers itself with the app dispatcher, and you provide a callback, right? And the callback gives you the action, which is the object that you pass around in the dispatch. So, going again back to actions, right? Here's that object. That's the action that you're going to get. So we go back, and what we do is we use this action map. Again, this is overkill. I don't know why I coded it this way for this presentation. But if you had a lot of actions, which is probably the case, you'll have something bigger like this, right? But the idea, the reason I think I honestly did it was to show the power of all of the abstractions that you can build. So we'll get on that in a minute here. So what we do is we grab the action, and then we call it, right? But we have to check to make sure it exists first, because someone might pass in an action from that's supposed to only talk to a different store. We're still going to get called here. So if you have multiple stores, all the register methods will get called. So we got to make sure that we're only calling stuff that we care about. So if the action isn't inside of our action handlers, we don't care about it. We're going to return and bail out of the function. Otherwise, we're going to call it, pass in the action, right? Go up here, we call it, we grab the weapon ID using object destructuring. It's an ES6 thing if you don't know about it. And then all we do is we check to see if it's included. If it is, we deselect, and we tell the store to emit a change. If the size limit, though, has been reached, then we just return and don't do anything because we don't want to add any more items. And if you notice here, I'm using the same constant that I use in the component to change the class names, so that's pretty handy. Then I select it and emit the change, right? But you see there's a lot of duplication here, right? You're doing something, you're emitting a change, right? An action gets called, and that just calls something else, right? So really what you could probably do is write a store factory that injects all the stuff you need, and you just pass in your state object, your action handlers, and that's it, right? But this is essentially how they have it set up in their example. Just a real quick look at the other one. So if we look, trying to remember what it's called. On the fly. So let's just do it this way because then I can see what I'm looking at. So we're going to look at the weapons real quick. This one's a little bit more complicated. Actually, no, it's not. It's way easier. That's not what I wanted to look at. No, we want to look at the actions. Okay. So the reason we want to look at the actions here is because this gives you kind of an idea of what it is to actually integrate with an API inside of a React app. So honestly, they don't really enforce anything. So again, anything goes. But this was an abstraction that I felt comfortable with. Really what I do here, right, is I include the API. And that's just it's just middleware. It's just an API layer. I don't actually have an API here. So all I'm doing is I'm calling the callback that's provided into this get weapons API method and then giving a fixture of weapons, right? So nothing magical happening there. But you would typically, create a separate object to interact with, any APIs that you have to interact with. So anyway, we look at where the API gets called. So here, it gets the weapons, right? Error response, typical node stuff. And normally we would catch the error or do whatever. But in this case, we're just going to pass on the response. But the one thing here, though, is that this response isn't quite right. So if we look at the fixture, right? So here's all our data, right? Here's our damage, our description, our attacks, whatever. The thing is, though, is that when we pass all this in, right, we need this data to work inside of this component, right? These little blobs that, I don't know, it's like chocolate. I'm not really sure what you'd call that, color scheme. It's pretty god-awful, but I like it. It's anti-design. So really, we have to fix this data so it can go into that component, right? Now, because I control the fixtures, I could just set it so that it goes right in, right? Now, if you have that prerogative, maybe that's a good, better alternative. But generally speaking, you're going to be getting data from an API that doesn't have a specific consumer, and you're going to have to adapt the data, right? This is where Immutable comes into play. So if we go back to the actions, right? I figured this was the most suitable place to do it, but there's probably other places. But inside here, I have this format response method. So this is kind of a doozy. But I will walk through it. Let's make it a little easier to read here for the sake of the screen resolution. And if you don't understand anything on here because you haven't used ES6 or whatever, and I'm not covering something and you're confused, please just interrupt me and ask. So here, it's actually kind of interesting, right? So if we look back at the weapons, right, we have an array of weapons that have all these keys on them, and then we have attacks, which is another nested object, and stats, which is another nested object. So what we want to do is we want to, make it look like something that the component can actually consume. So we go back into actions, we look at how we're going to format it. So the first thing we do is we map over it, and that gives us each weapon, right? And then what we're going to do is we're going to use Immutable's methods, right, to perform manipulations on that weapon. So if you're familiar with Lodash and use Lodash at all, they have a method called through. It's very similar to how update here works. But what this basically does is it gives you the value that's currently at stats, right? and then it gives you the objects to manipulate. And then whatever you return in here is what it's going to set stats to after it's done, right? So basically it's kind of like, hey, take weapon.stats equals this change, right? But it's using immutable methods. Also wanted to note here, we're using from.js, which does a deep casting, right, from an object or an array or whatever into an immutable structure. So if you have an object of an object of an object, right, it'll make sure that all of those are maps. And one important caveat to cover on that note is that you don't want to mix, right? You don't want an immutable map that has native objects that has an immutable map or anything like that. You want to make sure it's all immutable or all not. The reason for that is because when it comes to doing those comparisons, it'll totally barf, right? It'll get to that native like object and be like, I don't know what to do with this. You know, it's not equal, whatever, see ya. So, you know, just make sure that, that you're making sure that your entire data structure is immutable all the way through. So what we do here is we've got the key value table, right? So I wrote this method called format collection for key value table. I wonder what that does. So we look at it, and right, the reason I pulled this out of a function, obviously, is because I can compose it, right? I can use it twice. That's one of the cool things. So this is a good example, I think, of how immutable like really shines, right? Because what we do here, right? So in this case, it's either stats or attacks, right? We map over it, and then what we do is we want the label, right? So we're looking like, we don't have description, we don't have strength, we don't have range of attack, right? Traditionally in an app, the way that would work is you probably hit up an API that gives you a dictionary or gives you something for localization, right? So in this case, we just have them inside of our own constants file. But you know, typically that kind of stuff would come from an API. But even if it doesn't, right, this is a suitable way to approach it. So here, all it does is say, hey, for this key, give us this label. For this key, give us this label. So we actually go back to weapons. And yeah, so it just returns a new immutable map, and it grabs the value that is from whatever dictionary that you pass in, right, or map, or whatever you want to call it, and then just passes along the value. And so then if you go down and look, right, we're passing in these reference dictionaries saying, hey, give me the stat names by key and give me the tag names by key, right? So like I said, it's a little daunting at first, but if you write functions that tell you exactly what you're doing, it can be pretty easy to manage. And honestly, you just get used to looking at it. So that's a pretty good example of how it works, right? We format it, and then we pass it into the store, right? And then the store will set it, do whatever it wants to do with it. Typically, I would opt to do the immutable conversions inside of the store, so that way only the data store itself is responsible for how the data looks. But in this case, I wanted to show you kind of the cool part of immutable, right? We could have done this with Lodash, but avoiding mutability still would have been kind of a pain in the butt. So that's kind of how it gets formatted and pushed down. And then if we look at the key value table, right? Prop types, this is exactly what we wanted, right? We wanted a label, we wanted the value, and we wanted a map of that stuff. So what we did is we took the data we got in from an API, we changed it, stored it, passed it down. You might be asking, why don't you do this conversion in the component, right? Now you totally could, right? You totally could, you know, pass in the weapons, get all the way down to where you're going to call the key value table and say, hey, you know, do this. I want this immutable, right? Change how this looks. In some cases, you can do that. If it's really simple, you can do that. But in any case where you're actually generating a new immutable structure, you want to avoid it. Because what's going to happen is that if we look back at that example here, oh, that's the wrong one. So we look back at this, now it's actions. Man, I'm on top of it. So if we look here, right? Oh, I just forgot what I was talking about. Give me 1 second. I'm totally losing track of my stuff. So yeah, okay. You see here the label value, and we're talking about why we don't want to do that conversion in the component. So we go back to where it gets formatted. You can see here that it's returning a new immutable map. So if we do that in the component, that's totally going to trash your render mixin, right? Your pure render mixin, or being able to tell whether or not anything has changed. Because whenever you create a new map, nothing is maintained in that, right? You don't get to keep the references to any old objects. It's creating a brand new object. So what happens is that if you do that on every render cycle, that poor subcomponent or child component is never going to get the same data. It's just always going to have to re-render because it's like, dude, I don't know if this is new. I guess I'm just going to render, right? So you have to be aware of those kinds of implications. And so in this case, I opted to put this formatting before the store, so that way when it gets passed into the component, it just passes in. And if it does reference checks, it's, you know, totally cool. Albeit, you know, in this case, like, if you change the whole weapons, it would change it anyway, right? But it's good to know that, you know, the component is more simple now, and it's easier to see what updates. So this is the table component. This is probably the last thing I'm going to show you with the app, because it's got a couple cool caveats in it, right? So we pass in this data. It's a map. And then we run this method. So you can see here how this reads a little bit easier, right? I use an underscore to say, hey, this isn't going to get called. But honestly, I think it's mostly beneficial just to disambiguate your methods from like React's lifecycle methods. So component will update won't have a, you know, an underscore before it, so it might be advantageous to do it. Whatever you want to do. But I abstracted it out here, and it renders, you know, all these rows. Grabs the stuff it needs. But there's this toArray thing at the end, right? Like, what the hell is that about? The reason that that's a thing, right, is that this is an immutable map, okay? And this is not something that you're going to learn from a tutorial. It's something that you're going to be writing your app, and it's just going to come up, and you'll be like, what the hell does that mean? React doesn't let you iterate over immutable maps and then return them and render on them, right? So with a map, order is not guaranteed. Right? You don't get order. I believe they can guarantee the order that they're added in, but it can't guarantee order the same way an array can, right? So when it comes to rendering it out, comparing and diffing, when you don't have you know, the consistency of where the map will be, right? It can't always make the most educated guess as to whether or not anything has changed. So generally speaking, it's like if you just try to map over this, right? This immutable method map, right, will always return the same collection that it started with. So if you pass in a list, it's going to return a list. If you pass in a map, it's going to return a map. So in this case, props.data is actually an immutable map. So at the end of this, you get an immutable map, which again, React will, you know, consume and say, hey, what the hell are you doing? So I just cast it to an array at the end. It's kind of dirty, but from all the solutions I've seen, that's really the best way to do it until there's something else they introduce to mitigate that. So that's pretty much, you know, it, right? And the beautiful thing about this is that I didn't write any DOM manipulations, right? I didn't do any of that garbage. I didn't have to have a bunch of edge cases to look out for, right? It's just kind of manipulating structures, right? So here, when I click on Cane to Destruction and I click on Summon Dad Staff, that unshifts the Summon Dad Staff onto the array, right? And then if I click it, it, you know, pops it off. It's really simple, and then it just works, right? It just works. So I'm a huge proponent of React, obviously. I love it. I think it's awesome. And I don't miss writing DOM manipulations. You know, I don't miss having to have standards of you only use classes for CSS and you only use this for JavaScript and all this other stuff, right? Like, how about you just glue the two together and it just, you know, works. So I think it's a really powerful concept, but it is uncomfortable if you're not used to it at first. So that's pretty much it on the app. Were there any questions specifically about the implementation, how it works, anything at all? I know I was kind of bloaty and it wasn't presented the best way, but if you know, I can definitely try to clear anything up if you have any questions.
Can I just get one question out of the way?
Yeah, totally. What's that?
What editor was
Vim. Yeah, I'm a Vimmer, or whatever you call people who use Vim. Vim sapien. Any other questions? Cool. All right. So I'm going to go over one last little bit, and then we're done. Great. So let's talk about gotchas with React, right? So I covered a couple of these, but after seeing some code and seeing how it works, right, and at least having like the idea of the architecture in your head, right? One thing you want to do is you don't set state manually, right? If you look at React's documentation, which is actually quite good, it'll say that you don't want to do this. So in this first instance, what we're doing is we're assigning state data, you know, directly. The latter one, we're using the set state method. This is important, or this is very important because you might have multiple spots in your component that update the state, right? So when you use the setState method, it reconciles all of those properly. But if you're actually editing the state object, you're gonna have a hell of a time. So just don't do it. And it says in the documentation specifically not to do it. And there's a lot of gotchas like that with React. You'll find that you won't get yourself into lots of technical debt because of the framework. You'll get into technical debt based on how you implemented things, right? So here's another good one to know, is that you don't want to pass anonymous functions as props, right? So I actually cheated and did that. So if we look at the weapon list here, components, I can't spell. Oh, it must already be open. And it's so great. Damn, what the hell? I lost it. I feel very ashamed as a Vim editor right now because it's like, I probably have to clear my cache. Okay, weapons. Here we go. It was way more difficult than it needed to be. So here, right, if you're not familiar with the arrow syntax, this is essentially what I'm doing. So the reason you want to do this, okay, is just like an object or an array, right, a function is non-immutable. So if you, every single time that you pass this in, you're creating a new function. So this list, really, you know, it's always going to render out, right, every single time. Because you're always passing in a new function, right? It's always going to render something different because the props, even if like your class name is going to be the same and the name itself is the same, if something happens in the UI to cause a change, this will still render even though you don't want it to, right? So to mitigate that, right, you want to use component methods. So looking back here, you know, we have this handle weapon click, but the reason it's an anonymous function is because we're passing weapon ID in, right? So what we really need to do is pass in it as a prop, right? Weapon ID is equal to weapon ID. And then inside of here, oops, I deleted more than I wanted it to. We just pass in our component, right? So that's in our handler. So we just pass in this, and that will work, right? Because this is always going to be the same method in between every single render, no matter what. Like you create this function once, but you pass in the weapon ID. So the way that works, right, is that whenever you call handle weapon click inside of this list, right, then you would pass it along. But this is assuming that this is actually a component, right? So this would be like weapon item or something as opposed to a list. Because obviously what I'm doing is the best I can do with a list, right? You have to use the anonymous function, otherwise you can't pass along weapon ID. So if you can, avoid it. Right, and that's gonna bite you because you wonder why the hell your component is re-rendering or it's not re-rendering. It's usually, or it's not usually, but there's a lot of times it's something like this, right? You'll find that you're creating new props and you don't even know it. Another good example here is just take a literal array, right? You have 2 items in the array, but what's happening is that every single time you call this function, you're creating that array over again, right? So the reference, it's always referencing a different, actual variable. So what we want to do is we just want to make the items once and pass it in. So just kind of get that into your head, right? Like any children of the props, like either need to be immutable or they need to be, actually they just need to be immutable in general. Otherwise you can't really count on React doing its job as well. A couple other caveats. Again, I've gone over this. Keep your components simple, right? If it's starting to get crazy, move that stuff into actions, move it into stores, move it, like abstract it, get it out of there, because that really, really reduces reusability, and it just makes it hard to maintain. I mentioned this before, but you want to avoid creating immutables inside of your component. So you don't want to do what we did before, where you map over something and return a new, fresh immutable, because React will never know if it changed properly. Excuse me. And refactor as you go, right? And that's really any project you're ever on, right? But I think it's crucial in React to make that a point because, again, it doesn't put you into a specific, frame of mind, right? You really have to dictate a lot of how your app works and how it's built and how it's structured. So make sure that you're being cognizant of things as you change. Like, you know, looking back at our app, right? If we created 5 more stores and we had to keep making all of those like helper methods and like the event emitter helpers that we attach, just make that once and, you know, make it a factory and simplify your code, you know, delete like 30 lines. So just always like stay on top of where you're starting to reuse stuff, because with the React app, generally there's a way to reuse a lot of stuff. So just a couple helpful links that you obviously can't click on, but you know, if you pull down, you can see. The React documentation is actually quite good. It's very succinct, very good. It points out all the pitfalls that I've mentioned in some shape or another, and it probably takes like 20 minutes to read through the whole thing. It's fantastic. Immutable, its documentation is okay. If you know, it's all in TypeScript. So if you're looking at like all the actual method signatures, right, you'll see that it's all using TypeScript. So you kind of have to get used to that, but it's not bad. And then Flux as well, the actual repo itself has a bunch of example projects that use the whole stack, right? They don't use Webpack, they use Browserify, but you know, you could still get something done. I would definitely recommend looking at those example projects if you decide to go with the Flux architecture. They're really, really great. But yeah, if you go with Redux or Reflux, obviously those aren't very useful. So yeah, any questions?
Could you walk us through, I don't know I'm asking you to do this, but could you walk us through how you would add another one?
Yeah, sure. Not a problem. You guys cool with that? You guys cool if okay, all right, just want to make sure. So the question was asked for me to add another weapon, so I'm going to do that to show how it boils down. So that seems kind of fun. Let's do that. All right, so what we're going to do, basically because, again, we don't have a real API, it's just a fixture, all we're going to do is add another item here. So I'm going to go ahead and copy this guy, and let's make this together, right? All right, so what's an attack? Someone, actually, no, let's start with a name, right? What's this weapon? Someone give me a weapon name. Anybody? Halberg? Halberd. Any other? Nunchucks. What is it? Axe rifle? So it's a rifle that shoots axes, or it's also an axe? Oh, okay. So axe rifle, also an axe. Okay, so the description. I don't know, enough said. Strength required, I don't know, probably like, let's say 20. Need a lot of strength to handle it. And let's do, I'm going to leave this ID 3, so it'll throw an error. That'll be good to see. Images, well, we don't have any existing images. I guess let's use Jim. You know, that seems like the best option. Jim is an axe rifle. Guaranteed, okay. Description. All right, someone give me a description. Tear it up, I don't know. Yo, dog, I heard you like axes, so we put an axe on your rifle so it shoots out axes. I don't know. This is self-explanatory. Shoot axes. Range. Unlimited. Damage. I don't know. Yeah, unlimited. This is the Superman weapon, right? As much damage as you need. Okay, so we added it in here, right? It should just work. It should just show up. Let's hope it works. Fingers crossed. Oh. So I might have to actually redeploy it. That, or there's I missed a comma or something. Weapon.get name unexpected token. How could you? Okay, so just to make sure. Let's see, get checkout. Uh-oh. Well, that's okay. Still got it here. Woo! Yeah. You guys ever check out with 2 hyphens and then say, oh crap, I just deleted all my changes? It's definitely happened to me more than once. Okay. So we added them in, and if we refresh. Okay. So here is a really good error to be aware of that I didn't cover. So it said, encounter 2 children with the same key, 3. Child keys must be unique, blah, blah, blah. When they share a key, only the first one will be used. So this is important. Anytime you have an iterable, basically an array of elements, every single element in that array needs a key, right? It needs a key, otherwise React can't actually compare very well. It talks about that more in the description, right? So in this case, we'll just make it ID 4. And boom! Axe rifle, also an axe. This is a gem, right? And we're going to compare that with the flamethrower, right? So yeah, it just plops in there. Kind of cool, huh? Yeah. So were there anything specifically you wanted to go over? Just adding a weapon? Yeah, for sure, for sure. And you could set it up to where you have a button that would add it, right? And that calls the API, updates it, comes back down. But it's all the same principle, right? Your data comes from one place. Sweet. So that's it's really good. Any other questions? No. Cool. Well, thank you all so much. Oh, Seth has a question. What is it?
I don't know if you dug into Redux very much, but
Yeah, I think. Yeah, so I want to make sure I'm looking at the right, when you say Redux, I want to make sure I'm talking about the right one. Because, yeah, okay. So, yeah, they are pretty similar. I think, as you saw in the Flux implementation, there's some boilerplate that you may or may not think is necessary, right? The actions that spit off to the dispatcher, which then calls something else, which then calls your store, right? Like that's annoying. But the idea is that the dispatcher gives you kind of a wait for method where you can like say, hey, in this action handler, I need to wait for these other stores to do their thing and emit a change before I'm done, right? That's really what it gives you. So I think what Redux does is it takes a simpler approach. It only has a single store, right? So I know that that's one of the primary differences, right? So in Flux, you might have a store that tracks, say, the UI in this case, right? Weapons, you could do a lot of different things. But in that case, right, you just have a central store that has all your data. It's basically like, I think it's just a big key value pair, right? So you would have like, you probably have the delineation in the same way that we have the separate stores, but they would be different keys on the same object. And then as my understanding is that you write a series of reducers, right? Which is kind of what you saw before in that action. So when I do actions / weapons here, and I do all this formatting, right? I suspect, again, I'm not an expert on how Redux works, but I suspect that each one of these methods would be a reducer, right? So you get your big data store, and then you get these reducers, and then your components consume that data. But it's essentially the same thing, right? I think it also ditches actions. I don't know. Let's search for it. Oh no, it's totally still has actions. Does somebody here know Redux? Okay, sorry, I thought somebody just said it does, and I was like, wait a second. Oh, it's one reducer? Oh, okay. So it might be one reducer, is what someone said, and yeah, I don't know. Someone else did just inform me that actions do get passed. So yeah, it's essentially the same stuff, I think, right? But I would say that single store and the reducers is like the big difference. I think ultimately what you're going to want to do is look at your application, right, and see what your application needs are, right? See the domain, see the data that you're going to look at, and say, okay, how would it be best to manage it? But honestly, dude, Flux is probably dying in favor of Redux, it looks like. If you look at like stars, it's definitely beaten Flux by like 10,000. But Flux is still really viable, so you kind of just pick whatever works for you. They both have pretty good documentation on what they do. But yeah, I wish I'd looked more into Redux. So, any other questions? Awesome. Well, thank you all so much. I really appreciate it. I know it was pretty convoluted, so thanks for hanging tough with the banter. Appreciate it.
Good example.
Yeah, Axe rifle.
No, just in general.
Oh, thanks, man. I appreciate it. Cool. I don't know how